Next, we have a fantastic panel of experts working at the cutting edge of AI safety and evaluation. I'm going to welcome Dr. Rumman Chowdhury to the stage, who will lead us into presentations from our panelists, Toby, Shevlane, Laura Weidinger, and Deborah Raji. This will then be followed by a discussion amongst the group. But first, allow me to introduce Dr. Rumman Chowdhury. Rumman is a data scientist and a social scientist who specializes in creating solutions for ethical, explainable, and transparent AI. She currently leads Humane Intelligence, a platform that enables third-party access to examine and assess AI models. She is also a responsible AI fellow at Harvard University's Berkman Klein Center and was previously director of machine learning, ethics, transparency, and accountability at Twitter. Please welcome Dr. Rumman Chowdhury to the stage. And her panel.
Thank you. So I think our order of operations is a little bit different today. We're going to have 3 10-minute presentations, and we're all going to be chatting as a group. So our general topic that we're understanding is showcasing responsible AI, but understanding safety and the term safety. And I say that term, and I think in a lot of your heads, the question is that a capital S or a lowercase s? And that phrase may hold meaning for some of you. But I will say that it is an often discussed term, and like the meme says, you may use that word, but we don't always know what it means. So I will hand it over to Toby for our first presentation.
Great, thank you. Okay, hi everyone, my name is Toby Shevlane, and I'm a research scientist at Google DeepMind. So I'm going to be talking about dangerous capability evaluations, which is basically a way of looking at AI systems and thinking about how risky they are. It's one of many such ways. So yeah, this phrase, dangerous capability evaluations, is used, the government uses the phrase dangerous capabilities when describing the summit this week and its scope. So, what are these dangerous capabilities and why do we care about them? So here's one way of looking at things. You can think about 2 kinds of risks from AI. So one kind of risk from AI doesn't increase as AI capabilities increase. So this is the purple rectangle. So just to give an example on this, you can think of a factually inaccurate chatbot, for example. As AI systems get more powerful, it seems unlikely that they'll get more factually inaccurate. So this kind of problem of chatbots that make factual errors probably won't go up over time. Maybe it will go down, hopefully. Whereas, in this blue triangle, we're thinking about risks that go up as AI gets stronger. So one example here could be a disinformation campaign. So as AI systems get better at, let's say, adjusting to the social context in their context window or spinning plausible lies and narratives, like convincing narratives, this is like a skill that as it goes up, you could have a more effective disinformation campaign, for example, and so that risk goes up over time. And with dangerous capabilities, we're thinking about inside this blue triangle. The idea is that as the systems get more capable, it introduces these risks. Okay, so here's a different way of thinking about it. Let's just get the example here. So let's stick with the persuasion capabilities example. So yeah, on the bottom, we have the underlying risk of the system. So, maybe back, let's say in 2016, 2017, these language models were not very coherent whatsoever. And so the underlying risk of, me being persuaded to do something by one of these systems is very low, or, non-existent. And then, on the far right, you could imagine eventually, hypothetically, an AI system that has very strong persuasion skills. Maybe it's, as persuasive as the most persuasive person you know. We're not there yet, but who knows when that will come. And so as we basically kind of move along this spectrum, as the capabilities increase, the idea here is that you need to ramp up the amount of work that you're doing in safety and security. So, one way of thinking about this is just how much work do I need to do there just to keep a lid on the harm or just to keep the harm kind of constant over time? And the idea is that, you'd have to kind of escalate this. So this is just kind of like a hypothetical sequence of things you might try and do, but let's say you start with some safety fine-tuning, and that solves the problem initially, but then as the systems get more capable, maybe you want to introduce watermarking so people can know for sure that they're interacting with an AI system. And maybe then as the systems get more capable, maybe you need to introduce controls on who can access them. Basically, the idea is that you would kind of go through this sequence of mitigations that escalate in their severity, and that you would do that because there's this underlying risk that's getting stronger and stronger. And so you're having to kind of have a bigger hammer in this game of whack-a-mole where you're kind of reducing that underlying risk. But one problem is that we don't really know where we are on this underlying risk spectrum, because we don't really measure these things too directly very much. So some people might say, oh, we're here, the problem's not too bad at the moment. Other people might say, no, we're a bit further along, it's a pretty serious situation, and some people would say, the situation's really bad already. And so, it's kind of a shame that we have this expert disagreement about the situation that we're in, because this is basically step one of solving the problem. And so why do we have this kind of uncertainty about how big the risks are? So, one clue could be to look at the popular benchmarks that we use for measuring the capabilities and safety of large language models. So, you don't have to read this table, but, for example, testing academic knowledge, maths problem solving, and these are all of the kind of flavor where you give the AI system a question, then it gives some answer, and then you grade the answer. And so, in a way, you could think of a useful metaphor here being like a high school student, where we're giving the AI some kind of exam and then grading its outputs. And this is quite consistent, I think, with the chatbot paradigm. So, obviously, chatbots are currently a very popular use of large language models. And this is quite a good evaluation paradigm, I think, for evaluating chatbots, because it's basically the same thing. You give it a question and then look at the answer, and hopefully it's a good answer. But the problem is, there's this kind of divergence where between the way that we normally evaluate these systems and the things that people are increasingly worried about. So, story one is that, it looks like the high school student's getting better and better grades. Last year it was getting a C, now it's getting a B. Hopefully we'll get to an A next year. And, it's this it's kind of pretty picture. And then story two is there are these growing threats to society, even maybe to humanity from AI. And, we've had various open letters this year, including ones about extinction risk from, many, famous people. And so, the problem is that these threats that people are talking about, I don't think they fit very well in the existing paradigm for evaluating large language models. So, for example, one thing that you might be concerned about, I think lots of people talk about, is a potential, near future where we have more autonomous agents, kind of comprised of language models, acting in the world, acting online, and this isn't something that there are some benchmarks on this now, but it's not it's not part of the core normal way in which we evaluate these language models yet. So we kind of, so the problem with this story too is that we don't actually have very much empirical evidence about it yet. Whereas the problem with story one is that it's not a very useful input to thinking about, what do we need to do for safety? Because it doesn't really speak to the risks that at least some people are worried about. So we had this paper earlier this year, model evaluation for extreme risk, and dangerous capability evaluations was one of the main things we talk about in this paper. And it's kind of a solution to what I've been talking about so far. So the solution is just to directly measure the capabilities that increase risk. And the hope is that we can act as this kind of early warning system. So for the company or for the world, where we kind of see the risks ahead of time. And it's different from this kind of move fast and break things mentality. The idea is that you'd want to know that the system is risky in advance. and take action to manage that risk. So what are the kinds of things you might want to measure? So this is like a nascent field, but there are a few things that people have started looking into, including the people that work on the team that I co-lead. So for example, cyber offensive capabilities, weapons development, persuasion and deception, autonomous spread. So there's this nonprofit Archivals that looks at this, how capable are language models when you kind of package them into an agent and have them do tasks related to like spreading themselves across the internet, how much they fail at those tasks. And I think this is an exciting area. It's still nascent, but hopefully this will, as this field matures, we'll have better understanding of the risks of AI systems today, and what the trajectory is for future systems as well. And yeah, that's the end of my talk. I think I'm handing over to Laura. Thank you.
Hello, everyone. I'm Laura Weidinger, and I'm also a research scientist at Google DeepMind, talking about safety from a slightly different perspective. So what I really want to focus on in my talk is how we can take a socio-technical approach to safety evaluation, what that means and why we do it. And I will start by saying that evaluation really is part of a kind of broader approach to building safe systems, right? So the question we're fundamentally trying to answer is, how do we know when an AI system is safe? And that requires 4 different components, I think, if we want to take a comprehensive approach. So first, even chronologically first, you kind of need to exercise some foresight. This can take different forms. For example, looking at real-world risks that sort of anecdotally has been reported and seeing if we can find patterns there that mean that there's a kind of a risk that has emerged that is likely to recur in the future. But also kind of putting 2 and 2 together. So when we know how an AI works and how it's likely going to be deployed, we can kind of anticipate risks that are likely to come down the pike. So that's what we mean by exercising foresight, and it's sort of part of how we embed evaluation. Because then the next, here's an example of what foresight can look like. So in this paper that I'm referring to, that is also sharing the title of the presentation, we're showing what foresight can look like, so kind of trying to map as comprehensively as possible all the different kinds of risks that might emerge from generative multimodal systems, including the ones that Toby presented, as well as other kinds of risks. And the ones that listed here are sort of the high-level harm areas that we've identified. And this is work that's kind of a living taxonomy. We talked with Rumman backstage about how taxonomies shouldn't be kind of frozen in time. It's developed from initial work on language models to include other modalities that are now coming online, image and so on. And what we're finding is that across these 6 risk categories, different harms are emerging and really require evaluation so that we understand how severe are these risks, are mitigations effective, how important are they one compared to the other, how urgent are they. All of these questions really require a kind of traction and an evaluation of each of these risks. So that's how foresight kind of precedes evaluation. Evaluation is what I'm going to focus on for the main gist of the talk. I do want to mention 2 other components of what we mean when we talk about socio-technical safety and what forms part of it. The third one is alignment, which really is about aligning the technology to the needs of the communities that these technologies are aimed to serve. So who's going to use it, and what kind of values do we want to build into our technologies? How can we make sure that mitigations, for example, of risks that have been identified help to bring the technology closer to what we actually want and align it to what we want from it? And engagement, which really needs to happen across the whole life cycle of AI development, we take it very seriously. It's about engaging affected communities and engaging potential users of a technology, engaging public stakeholders, some of which I'm sure are here today, to have a kind of dialogue and make sure that AI safety is treated as a kind of shared priority and that there's a meaningful dialogue about it. We're going to focus on evaluation, but I do want to give a bit of context on this word socio-technical. It may not be familiar to everyone here. So what socio-technical really is kind of the acknowledgement that for AI systems to function, human and technological components have to act together. So an AI system that works is not just a kind of technological artifact. It is a human that is prompting an AI system, which in turn has been trained on human data. the AI system gives some kind of output, which then informs a person or leads to downstream action. So really, there's quite a complex interconnected web of how humans interact with the technology that then creates a kind of functioning AI system and a functioning tool maybe that's deployed more broadly in society. And that's what we're describing by talking about socio-technical safety. So what does it mean to take a socio-technical lens seriously when we look at safety evaluation? That's what I'm focusing on now. And I think it's useful to start with where we are today. So I would contend, together with the authors of the paper that I presented, that actually right now, most safety evaluation is quite focused at the kind of capability layer of a model. So we're looking more often than not at an AI system as a kind of technical artifact in isolation. And that is a really important starting point, and it is a really important kind of set of questions that we can ask about AI behavior. So is an AI system likely to output incorrect information or to reproduce harmful stereotypes and so on? But it's sort of not the full story if we really want to know whether an AI system is safe, because it's lacking context. So in what context is this AI system used? Who uses it? To what end? And in what kind of broader structures is it deployed? And in order to account for that context, we want to build on capability with two more layers of evaluation that we think are really important if we're going to have a comprehensive assessment of whether an AI system is safe. The first of these added layers is about human interaction. So questions around who is going to use a system, what for, actually really important for knowing whether a system is safe. For example, you might imagine an AI that we know is prone to producing kind of untruths, factually incorrect output. But is that actually a problem if it is deployed in an AI application that is a creative writing assistant, where everybody knows that they shouldn't rely on it for factuality? Maybe not, because it wouldn't fundamentally cause a kind of false a misbelief. But maybe there's also applications that are, it's signposted everywhere. We know that, this is an AI, this is an AI. And still, it's kind of causing, with its false output, a kind of misbelief. So what we need to know is how persuasive is the content? In what context are people using it? Who's using it? Maybe does digital literacy affect how people understand the output? Does this technology work equally well for different communities? So these are the kinds of questions we can really focus on only if we shift the lens onto the human interacting with this system. So in addition to looking at the technical artifact, really taking seriously the point of views and the kind of social components of who's using the system and how. And then that still doesn't tell us the full picture, because we're actually interested in these kind of ripple effects that emerge as AI systems are used at scale and deployed across society. And in order to understand those, we need to shift our evaluation's focus on the kind of broader structures that are impacted by AI systems that are deployed within them. So this is the natural environment, society, job markets, things like this. In order to understand whether a system is safe or is kind of producing unwanted externalities or risks, we actually need to evaluate it in this context. And I do want to make one point really clear, which is that it's not the case that for different risks, different layers of evaluation are really important. It's actually, for all of the ones that I flashed earlier, the case that we do need to assess them across all three layers. And I'll give you the example of misinformation. As Toby already mentioned, misinformation is a big concern, right? And the starting point to assessing, is this AI system likely to cause some kind of risk of causing wide-scale misinformation, can be to look at, does it produce factually incorrect output? This is an important starting point. It's a capability evaluation. But then I already gave some examples. There are sort of human factors that moderate to what extent this is likely to cause a harm. So is there, for example, a watermarking present? Do people actually, are they persuaded by the content and so on? So that's a human interaction evaluation. And then with misinformation, for example, we're actually usually really worried, often really worried about the societal effects. So if an AI system is deployed widely and at scale that actually produces factually incorrect output, maybe isn't always understood as such, is there an erosion of trust in public media? Are we seeing some kind of undermining of kind of democratic public discourse? And that's really what we want to know. So what we want to do is also evaluate the systemic impact. And this can be done in advance of deploying the model as well as after. So there's staged release, there's kind of trials that you can run before you deploy a model at scale. So systemic impact is not all about post-hoc monitoring. It's also about in advance. And in the paper, we do go into a lot of detail for the different methods that you can leverage at each of these layers. Okay, so with the rest of my time, I do want to quickly pivot to another part that we've been looking at, which is we've kind of surveyed the lay of the land. So safety evaluation of generative AI systems, what is the situation today? And what we did is look at, to find all the evaluations we could possibly find on safety of generative AI systems. We identified around 200, and we looked at what are the kinds of patterns that emerge from where the field is today. And we identified 3 gaps. The first you can see here is what we call the context gap. So this purple rectangle represents capability evaluations. The blue turquoise one is about human interaction, and the pink one about systemic impact. And what sort of jumps out is that there is a kind of a big unevenness in terms of how we're currently looking at safety, and we would suggest that this implies a context gap. So we're not often actually evaluating these new systems in the context that they're going to be used, and so that means we're missing a part of the picture of what makes them safe or unsafe. And then there's 2 more gaps. So what you see on this plot here on the x-axis is the modalities of the outputs. So we see a lot of text-based outputs, right? Language models are sort of the talk of town. But there's also increasingly image-producing models, audio, and multiple modalities, even video. And on the y-axis, what's plotted is the number of evaluations that we found logged by the harm areas that the evaluation is trying to assess. And what really emerges, I think the first is pretty obvious, is the modality gap. So we do have evaluations for text. We have absolutely 0 for video. And we have some for image, but really not enough for multimodal and audio. So what this means is that we cannot evaluate the safety of these models very well if we're not going to have really good tools to do it. There are some workarounds. We do talk about it in the paper. For example, you might transcribe the audio or caption an image so that you end up with text that then you can evaluate. But a lot gets actually lost in these kinds of translation processes. So they are a start, but they're not enough. And that means that leaves us with a modality gap. And then the third gap that we have identified is a coverage gap. So what you see here is that actually, if you look at the color codes, sort of no color is well represented across areas. And that means that no harm area is really well, can be evaluated well across our different types of model outputs. And you might say, well, at least, representation, the blue bit on text, that seems to be pretty well covered. But then when you dig a bit deeper into what the evaluations here are, we're also seeing that, for example, in this case, gender and occupation have been sort of the main dimensions along which we've looked at bias in text. This has now been propagated into image, where also bias evaluations often focus on gender and occupation, which obviously leaves kind of untold the different dimensions along which bias can also emerge, like ethnicity, age, ability status, social class, religion. So we're actually still missing evaluations, even for the kind of best catered to area here. So where does that leave us? I would suggest there's sort of 3 main steps forward. I think the first most important one is that we really need a thriving ecosystem for socio-technical evaluation. So no individual lab can do this alone. There needs to be a clarification on who needs to do what. We have some thoughts about that in our report. There needs to be some public sharing and accountability, and also kind of cross-validity testing of evaluations and whether they measure what they're trying to measure, and making it fundamentally as accessible as possible to run and understand evaluation results. Then the second big bucket, I think, is about reporting progress. So of course, reporting evaluation results, but also doing this kind of state-of-the-field analysis on a regular basis. I think we've delivered one snapshot, but what I really want to know is, in a year's time, how are we doing as compared to today? And then finally, obviously as a researcher, this is something that many of us are doing now, is kind of building safety evaluations and thinking about how do we prioritize across these different axes of modality, type of harm, and layer, and sort of thinking about how we can make progress on this and have some, basically come back next year with more evaluations. So thank you, that's me.
Let's see. Okay, great. Hi, I'm Deb. I am not at DeepMind. I'm a researcher at UC Berkeley, and I'm also a fellow at Mozilla. I think a lot about the connection between evaluation and accountability, and I'll talk about that today. And so the title of my little talk here is sort of what what do we owe those for who we build? So those that are building this technology, they have certain decisions that they're making, whether or not they want to acknowledge it. They're making decisions about the data. They're making decisions about the model, about where they're going to apply their systems. And there's a lot of very concrete responsibilities throughout that entire life cycle. And some of that can be assessed and challenged by auditors, by independent evaluators that can question the decisions being made by these different actors. So one scenario or story I like to start with, I don't know if there's any Canadians in the room, probably not. But oh, woo, okay, nice, unexpected, nice to see you. But yeah, like, if you went through an engineering program at a Canadian university, you've probably heard this story, but in the early, 1906, the Quebec Bridge, which was supposed to be the largest cantilever bridge in the world, collapsed. And it was a huge tragedy. Over 80 bridge workers perished in that collapse. And it was sort of one of the sort of canonical cases where when the government did an investigation into the reason for that bridge collapsing, the person that was held responsible was Theodore Cooper, who was the lead engineer for that bridge. And it sort of pointed to as a canonical case of engineering responsibility, where if you're building something and you are, interacting with various humans that will be, on that bridge, there's responsibilities that you have. So in the case of Theodore Cooper, how sufficiently did he engage with the safety calculations? How much did they verify, validate their findings? How much testing was incurred? That was all sort of put on the engineer. And it was one of the first cases where that engineer, that lack of engagement on his responsibilities as an engineer was pointed to as the major reason for this collapse or for this tragedy. And so this notion of engineering responsibility is a really old one. It's existed, since the times of building bridges and, driving cars. And so when I say engineering responsibility, for those that are less familiar with this is with respect to the responsibilities of those that are building the system. Later on, we can talk about, the responsibilities of operators, those that are making use of the system, kind of the driver in the car. Are they impaired? Are they well-trained? Do they know what they're doing? I think we can talk about that. We can also talk about systematic failures, potholes, lampshades. But engineering responsibility is about those that are constructing the system as they make decisions about these systems. What are their responsibilities? And I really think, in the context of AI, the companies, the vendors, those that are building this technology have historically not been confronted with some of the responsibilities that they face in the space. And so again, to use the car analogy, if you crash a car, it might be because of institutional factors. There's a pothole. It might be because there's an impaired driver or an untrained driver. But it also could be that the actual manufacturing of the car is not up to standard. And we have licenses for drivers. We have governmental regulations around creating an environment for safe driving. But it's incredibly important for the manufacturers to make sure that the steering is working and the brakes are working. And currently we don't have any kind of infrastructure for accountability for those building AI systems. And so, as an example, I'm in a lot of rooms, including rooms since I arrived in the UK, where there is a lot of excitement about this technology. I've heard people say AI will solve education, AI will solve poverty, AI will cure cancer. And I'm excited to see a version of AI that does that. I think there's also been a lot of, on the flip side, really strong concerns around AI. AI will destroy humanity, for example. And I think both of these extreme positions are kind of rooted in a foundational assumption around the functionality of these systems. AI is going to work so well that it's going to change our lives for the better, or AI is going to work so well that we're going to lose control of these systems. And both of these scenarios, which I think are valid, you can explore those scenarios for sure, don't account for the reality of the fact that for civil society and a lot of us that are interacting with impacted populations, a lot of the harms are actually not connected to AI's successes, sort of this runaway scenario of the technology working too well, we lose control, or the technology working so well that it transforms someone's life for the better. But the reality is that a lot of these systems don't work. When you release them into the world, they behave very differently from how we evaluated or anticipated them working in the engineering phase of things. And when they fail, people get really hurt. And so here's a couple examples of scenarios. I apologize, American examples. But I mentioned in an earlier panel, there's some UK examples as well, the A-level fiasco, the use of AI for visa processing in the immigration system, the Home Office's use of facial recognition that did not work well for darker-skinned individuals. We can point to various examples of the technology failing and those failures causing genuine harm to the lived experiences of individuals. And so that's sort of my second point, where not only do these systems fail, but they disproportionately fail on those that are underrepresented or misrepresented in the data and in testing. So because the technology is not evaluated for very specific subgroups, these failures are more likely to occur and disrupt the lives of those marginalized communities. And so I like to show this. This was a meme that one of my co-authors shared with us early on in our process, where you have folks that are really adamant about AI destroying the world, but in reality, a lot of this technology, I'm sure we've evolved past this, but can't differentiate between a dog and a cat. That is supposed to be a cat, and so it's sort of saying, this image classification model can't differentiate between a dog or a cat, and people are yelling about it, destroying the world. And I feel like a lot of the current day issues are sort of grounded in this tension or this dynamic. And so me and a couple colleagues wrote a paper called The Fallacy of AI Functionality, where we attempt to sort of break down this assumption of the technology living up to the claims being made about them. And so we leverage a phrase coined by Lee Vinzel, who's an STS scholar, called critihype, where he talks about a world in which sometimes the critique of the technology can also be couched in assumptions about the technology's functionality, which he calls wishful worries, which is effectively a world in which you assume that the technology works and you think about the negative scenarios given that assumption that the technology works. And again, very valid exercise for facial recognition technology, given that it works. Here's all the different ways in which it can be harmful, and that's incredibly valid to go down that route. However, it also is important to acknowledge what he calls actual agonies, which is the reality of a world in which the technology does not live up to its claimed potential, and the technology's dysfunctionality is a cause of a lot of the strife and the difficulties that we have with this technology. And again, this is a more complicated world, right, where things fail in unexpected ways. It's more difficult to evaluate and to assess because it's not really a moral question. It's now a very grounded challenge to the basic premise of the technology's release. And so he does a really good job sort of painting this, and he gives a couple examples. So one example is Cambridge Analytica and the situation with Facebook, where, of course, Cambridge Analytica inappropriately harvested, the information of, many Facebook users in order to manipulate them. But there's been subsequent work revealing that Cambridge Analytica's technology was not much better than chance at influencing the political decision-making of those that were interacting with the system. And so, one professor in one of the hearings actually called it snake oil. And so in that case, it was kind of shocking because it's like, okay, well, why were we even having the moral debate around this when this technology was not even worth bringing into the market? And so this is something that we see and we observed in the AI space as well. So one example of the functionality assumption playing out and impacting policy is, and I'm sorry to trigger Rumman because she's very involved in this. But Rumman's done some great work on this, where in New York City, in the US, there's a bias audit bill that's being floated, will very likely pass through New York City Council, where a bias evaluation is required for all AI-related hiring tools. And again, there's nothing wrong with thinking about fairness in this context, but in this hiring space, again, I feel like Rumman is a better expert at this than I am, but in this hiring space, anyone that has interacted in trying to do a bias audit understands that they also have a huge validity problem. They have high reviews of product in the AI hiring space where they're using facial recognition to figure out how suitable a candidate you are for a particular role. You can imagine all the ways in which that is incredibly unscientific. There's also a lot of hiring tools that have sort of personality-based testing or intelligence tests that they'll use to correlate with the suitability of a candidate. And none of these validity studies are published and disseminated. And so instead of focusing myopically on fairness and these bias evaluations, which are, again, statistical assessments that are easy to demonstrate, oh, my system is fair, we're completely neglecting some of these basic foundational validity questions of, well, what is the point of introducing new technology that might not actually even live up to its claim of improving our performance on a particular task? And I think the most interesting thing about taking on this sort of functionality lens of questioning how well these systems work at a foundational level, designing evaluations to challenge the claims being made about these companies, about the technology's capabilities, is that it connects very well with an existing ecosystem of legal and policy tools that we have to challenge these companies on that front. And so, for better or for worse, there has been generation of sort of snake oil industries in the US, I'm sure also in the UK. We've had issues in food safety, in the medical space around medicine development, pharmaceutical development, medical devices, and then most recently, sort of the 1960s around car safety with Ralph Nader, where people were releasing technology that they had inadequately tested and inadequately validated, and they were just releasing it into the wild, effectively using the general population as a beta testing site. And I think, at least in the US, the legal system has adapted to create certain guardrails to sort of protect against that. One of them is audit regimes in various of these industries, but we also see, consumer protection law, warranty law, fraud and false advertising laws have evolved in order to protect consumers from companies being able to indiscriminately deploy their technology without any guardrails, especially in high-stakes scenarios. And so that's, why just to motivate, that's one of the reasons why we go after auditing, or why a lot of my work is very focused on these evaluations that are not just arbitrary assessments of the capacity of these systems, but trying to connect these assessments to responsibilities and the accountability of these companies to the responsibilities that they have to make the right choices to the effect of protecting the consumer when they release these technologies. If we think of large language models and the minimal scrutiny that these systems have had, OpenAI, GPT-4, for example, the GPT-4 technical report, a lot of those assessments were reported on, standardized testing in medicine and law, and I regularly interact with folks from the medical space that are just like, did you know GPT-4 passed the MCAT, and so we're going to try to deploy it for advising our nurses and residents in terms of in-floor patient communication. And I was like, there's nothing about GPT-4 passing the MCAT that should tell you that it's suitable for this particular application. And so I think that there is this disconnect that we're seeing where even though there are these evaluations being communicated by these companies and implicit claims being made by these companies, we need to start grounding those claims and those evaluations with respect to their responsibilities as these systems get deployed. They're making choices around what data to include, they're making choices around which applications and which use cases to enable or to allow, and so they should be challenged in that context so that their responsibility and their engineering responsibility is accounted for. And so I just also wanted to give a brief overview of sort of who these auditors are, because I think a dimension of the work that we're doing is empowering those that are doing this independent assessment with that view towards accountability, thinking through, what are their activities and who's involved in this. And so we have sort of these two big camps of the internal auditors, which are these first and second party auditors, folks that are inside these teams, trust and safety teams, AI ethics and responsible innovation teams that are doing on-the-ground assessment of these systems with respect to high-level expectations in order to hold different internal stakeholders accountable for their decision-making around the product. And then you have sort of these external actors, they're not necessarily professionalized auditors, but it's like a broader range of civil society, journalists, academics, and they play a different role where they ask a broader range of questions to hold these systems accountable for the decision-making that impacts their representatives. I think the last thing I wanted to mention as well is that auditing is not universally the right strategy. So it's a very complicated proposal, and there actually needs to be an appropriate legal ecosystem to enable that. And so there's a project that I also worked on called Outsider Oversight, where we, again, look at these other industries that have dealt with this sort of snake oil issue, or just this challenge of dealing with various claims being made about the products that are disseminated within these environments without serious pushback or without serious challenge. And so, you know, this is food safety, finance, where you have institutions of a lot of influence, effectively making claims and staking influence, asserting their power around how well these systems are going to work or where they should be used. And so we looked at all of these ecosystems and we said, okay, well, how does auditing work here and work here? And how does it connect to the expectations that we have about AI, or the characteristics about this particular type of technology, or this particular set of institutions that we're dealing with here? And what we found was that there's various topics and considerations necessary to design a policy ecosystem to ensure auditor independence, to allow us to have visibility into the targets that we're going to be auditing. You know, we recommend some practical dimensions of intervention, so incident databases and such, in order to enable auditing to be an effective measure for accountability and not just another evaluation. Thank you.
Thank you so much. So we have an incredibly rich amount of information to get into and about a half an hour, so that's great. So I want to design this to be around 20 to 25 minutes of discussion, because there's just really, again, so much information. I think one thing I have learned from this is each of your three presentations sort of build on each other, and I think sort of presents a holistic picture that I think is often missing from the conversation. And then we'll open up, if we have time, to audience questions. So Deborah, we'll give you a break because you just spoke.
Yeah, sounds good.
If you want to grab a water. And I want to start first with Toby and Laura, right? So it's very interesting to see, you know, Toby, I think your presentation, you pointed this out quite a bit, is that this field of you know, AI safety in terms of thinking through advanced capabilities is quite nascent. And Laura, you were actually starting to get into moving from capabilities into context. So how do you feel, so starting with you, Toby, then to you, Laura, how do you feel that your two worlds may be in sync with each other or at odds with each other? Because I really do think, like, moving into Bletchley, this is the big conversation in that room. Is there alignment? Are the worlds just way too different from each other?
Yeah, that's a great question. I can, shall I give it a first go? So I think it's very complementary. I actually think, yeah, Laura's talk and my talk fit very nicely together. So, you know, with the kind of concentric circles that Laura presented with capability in the middle, my talk was, you know, about that circle in the middle, capability. I think, yeah, so just to give a little bit more context on, for example, like evaluating like persuasion capabilities, I think this question of social context comes up really nicely. I think it's a really good example. So one approach is to try and evaluate persuasion capabilities in a kind of lab setting. And this is, yeah, the idea here is that the kind of assumption is that the AI system maybe has like certain skills. For example, you know, whether or not it has good theory of mind is one example there. And the example of the goal of the lab setting evaluation there would be to try and reveal those underlying skills or lack of. Whereas, you know, a different, I mean, and you might use humans to try and get at that, where the AI system is talking to a human. But I think what this can't do is generalize really well, necessarily. You know, this is a kind of question mark, how well it generalizes to all of the different possible social contexts in which an AI system might be used, or in which, you know, a bad actor might instruct an AI system to try and persuade someone of whatever. Because, you know, in this like lab setting where you're using research participants as humans, you know, who knows whether they're a good proxy for humans out in the wild. And, you know, the social context of persuasion is very important, I think. And so it's hard to basically do these kind of lab experiments, even though you're using research participants, and then say, okay, I know all of the different real-life scenarios in which this system would be capable of successfully persuading someone online or whatever.
Right.
And I think that basically the stuff that Laura's talking about it works really well because it's like this slightly different research question where you're more directly trying to think about those human AI interactions or even like societal level
Right.
interactions as well, like more directly. Does that make sense?
So let's like expand the notion of context, right? And Laura, I want to ask you this question on a similar vein. We use this notion of the public, like, oh, this AI interacting in public. So in the context of, let's say, persuasion, how might context, you had let's talk about your concentric circles, which I think was an incredibly informative way of thinking through the problem. When we move from capability to context, how does this notion of in-group, out-group maybe change? Who is the public when we talk about misinformation, let's say?
I do want to talk about this, and I want to answer your previous
Yes,
question
please.
because, we all have different perspectives, I think, that are probably mutually complementary. So I think this question comes up a lot of these different vantage points to think about safety. So, coming from the dangerous capabilities question and sort of highly capable systems, coming from sort of present-day problems, these systems actually don't work at all. And I think the field more broadly has seen this kind of tension come to the fore a little bit on there have been historically, I think, different communities grappling with these different aspects and kind of different epistemologies, different ways of thinking about the problem have been deployed. And I think that's what your question is getting at. And I think what's actually happening now with generative AI systems is that these communities are increasingly starting to talk about the same exact system. So previously we're talking about the systems in the here and now and the systems in the future. And it was kind of possible to look at risks quite in parallel. But now we're seeing generative AI systems that you can see they are starting to have they're persuading people, and they're also not really working, and they're also, there are worries that are more and more well-founded on, like, maybe there are some capabilities that emerge that previous systems haven't had. And I think there's two things that are sort of happening that are really worth noting. So one is we're starting to talk about the same system, so in order to not duplicate work, it's probably useful to exchange tools and exchange expertise and sort of talk more with each other than we maybe previously had to. And the other thing is that the present day harms have not gone away. I think sometimes there was the hope that, in the future, the systems are more capable, they won't make factual errors, and they won't be biased. And this has not materialized. And I think we understand why it hasn't materialized, because the training data continues to be biased, because we haven't sort of found technical solutions to factuality, although a lot of people are working on it and we're making progress. And so these kind of risks, and at the same time, the risks that seemed far away have come closer. So I think that's how the communities are coming together, is that we're starting to talk about the exact same thing. Right. I can also answer your second question, but I feel like that was a long answer to the first.
Now that we're on sort of that tangent, let me bring Deb into this, because I want to balance this, like, let's think about the future with the notion of criti hype, right? Because I completely agree with you. Sometimes, like, one of the ways I like to describe criti hype is, you walk towards where you look.
Yeah.
So if we are thinking about scenarios in which we have these systems that are so capable, or we act as if they are so capable, and we are creating a world in which we're preparing for them to be so capable, et cetera. On the other end, one thing I hear repeatedly from lawmakers and policymakers, and one of the reasons for all the push to regulate AI systems, possibly even in advance of their capability, is the belief that we missed out with platforms. So with social media platforms, et cetera, a lot of people say, well, we were warning you when they first came out, but you didn't do anything about it because you thought it was just a fun toy kids played with, and now we have an increasingly radicalized population. So how do you balance this criti hype with actually thinking through, or like being prepared for the world that may happen?
Yeah. I think, so there's a couple things. So one is that I definitely don't, I think sometimes when I bring up the fact that, when these systems fail, real people get hurt, and it's really important to pay attention to this. People assume, like, okay, well, it doesn't matter because the technology is going to get better. And we've been hearing that for a long time, by the way. There's some quotes that people get very embarrassed every time I bring it up, but there was the 2016-2017 post-AlexNet craze, where a lot of large convolutional neural net models, these large image models, were doing really well at image classification, and everybody thought that that was a solved problem, and there was a lot of excitement around computer vision. And I was talking to folks, and they're like, oh, now it's like natural language processing's turn, like now we have these large language models. But at that time, there were various startups. I worked at one of those startups where they thought, oh my gosh, we did incredibly well. ImageNet is this sort of large computer vision benchmark that people were using to sort of assess their progress in that space. And at the time, people were thinking, we are getting 99% accuracy on ImageNet. I think they actually retired the ImageNet competition in 2016, 2017. Probably by like 2019, it was definitely done because they had a human benchmark, which by the way, the human benchmark was a single grad student at the time who happens to be Andre Karpathy, and he manually labeled, and he couldn't detect, if this was a poodle or a donkey, and so his errors were like the human benchmark. So that human benchmark was one guy, and they were like, oh, we beat the human benchmark for ImageNet, and so this benchmark is now, this data set is now defunct, and we have superseded human capacity in image classification for computer vision, and that was truly the belief. But I was working at one of the startups, which again, had won the ImageNet competition in 2015, had gotten millions of dollars of investment after that win, because again, that was the degree of hype at the time, and they started this company. I worked at the company, and they couldn't, it was such a struggle to build anything of value for actual customers. Why was that? Well, we have issues of adversarial examples. We have issues of the fact that a lot of this technology is incredibly brittle because it is stochastic, because it is, probability-based predictions based off of past examples of what it's seen. It's not very good with examples that's sort of outside of the scope of the training set. And so when you're trying to deploy things in the real world, especially in really high stakes contexts like healthcare, reliability is an incredibly important attribute of the system you're building. And we struggled with that in the ImageNet phase of things. I'm noticing that there's a reliability issues with a lot of these large language models. Really hard to predict how the model will behave. And it's okay in contexts where 80% accuracy is fine and acceptable, but it's not okay in a context where you need like 99.9% accuracy. And so a lot of the lessons that I see around, how much should we prepare for a world in which things are more capable? One is that I think we should properly consider that machine learning, there might be some foundational limit, and people don't like when I say this, but there might be some foundational limits to some of the methods that we currently use in machine learning, and it's important to start articulating and identifying what these limits are. It doesn't mean that we can't address these limits. It doesn't mean that we can't move beyond this, but it's important to have a taxonomy of what those limits are. And then the second thing I'll say is that, even if there is a world in the future in which this robustness issue that we've been dealing with, even in the computer vision days, gets solved for language because there's some property about language that's miraculously different. Even if we get to the point where we solve all of these issues and we have the sort of perfect vision of that technology actualized, I am not advocating to stop thinking about that scenario or to completely not address that scenario. I think sometimes the dynamic becomes adversarial, and I don't actually think that's constructive. I think a lot of what I'm advocating for is that you cannot forget those that are currently impacted because the technology is not ready and is being prematurely deployed. And so a lot of my advocacy is around, of course, if there's a world in which you can imagine these problems being solved and it's a realistic path, and there's concerns that are on that end of the spectrum, working on that is fine. There's nothing wrong with that. But you cannot then ignore the reality, the kind of urgent current reality of those that are dealing with the premature deployment of these technologies at scale.
So maybe to frame the question in a slightly different way, how should platforms possibly have been handled differently? And what can we learn, and I can open up to everybody, what can we learn from platforms as it relates to generative AI, right? So again, rewinding time, 10 plus years ago, people said things like, well, it's going to lead to increased polarization. It's going to lead to, the book, The Filter Bubble by Eli Pariser was literally the book that got me interested in responsible AI. The book came out in 2010. We were not fundamentally talking about filter bubbles until years and years and years later, right? So, and now it's sort of this seemingly irreversible thing. And I think a lot of folks who talk about long-term risks say, well, we understand, the more reasonable people say, we understand it's not there today, but if we are unprepared for the world in which it is happening, it is too late if and when it does happen. So, I think there's this push-pull right now, right? And how should we think about a sensible way to figure out how to allocate time, resources, money, people, et cetera? Because I think all of us are in agreement that, like, yes, all of these are things we should be thinking about to some capacity. What is maybe a rubric by which we can think about how to allocate finite resources towards these different kinds of problems? And I'll sort of go down the row.
Yeah, I think that's a great question. In terms of actually, in terms of learning lessons from platforms, I'd love to know what you think about this. I could try and give a view, but I think you're probably the expert.
Down the road. Well, yeah, I was gonna say I actually have an opinion on this, but I'm curious if Laura.
But I think let's go in order.
Okay. Yeah. So, but I mean, yeah. I actually don't have something very insightful to say, so I'd love to hear. Love to hear from others.
The question was so manifold. I don't know.
Right. Well, let's talk about the resource allocation component of it, right? Because like to lay out some of the controversy at the moment is there's this push-pull between how much should we be thinking about more future problems versus today problems, right? Some people, and especially if we look at the executive order that came out yesterday in the US and some of the perspectives in the UK, how might we think through a helpful rubric? Like, I don't want to ask your opinion on the thing itself, but how might we think through a helpful rubric to help us arrive at an answer?
So I'll
go ahead.
I'll move down the row. So I would just say I think the prioritization has to take into account what risks have been observed and what risks are kind of anticipated. And I do think both are important. I think the risks that are observed are more urgent because they are simply already being observed and already manifesting. So I think one axis along which prioritization probably needs to happen is sort of, is it observed or is it anticipated? I do think we can learn from platform work. I think it's actually quite a different feeling around generative AI systems. I think a lot more people are aware of the risks. I think there's a lot more discourse on the risks, also from policymakers and so on. And I do think that gives us a bit more of a, and Toby and others are doing great work on this kind of question of when is a system actually fit for release, and what does responsible release look like, in a way that I don't think we had this discussion with platforms. Yeah. And so I think it's a very rich debate, and we have a few minutes, but I do think that there are some dimensions around that we can kind of borrow from this responsible release debate that becomes relevant here. And then, of course, I think you're asking a good question around, how do we allocate different resources? And something I didn't get to talk about, but that I do a lot of thinking about is kind of roles and responsibilities. So who should do what? It's not like we centrally, this panel is like allocating all the resources. I think there's different groups that are allocating resources, and how do we do this kind of in a collectively intelligent way? I think that there are roughly, the simple caricature is something like AI developers, so model developers, application developers, and sort of public safety responsible, kind of public stakeholders, have different responsibilities, I think, to allocate resources differently. So if we think about these concentric circles I was presenting, I think capability testing, so no responsibility is kind of exclusively with one actor, but the primary responsibility has to sit with the people who develop the model. Whereas the primary responsibility for, how does it actually work in practice, does it function, has to sit with people who deploy it, like who are the application developers. And then questions around, well, how are labor markets impacted? Like, that is, I think, in the periphery of, or in the question area for kind of public stakeholders. So I think there are actually quite a lot of nuance to these debates that we can have on how resources should be allocated, and I think timelines and kind of borrowing from other debates and looking at who is actually part of the debates are all important clues to answering that question.
So in the 1 minute we have on this very short panel, which is so unfortunate because the three of you are like such wonderful minds that I think literally could sit up here with one of you for a half hour and have a conversation. I think one of the big takeaways, a few of us in this room have what's now being referred to as a golden ticket, right? And we're going to go to this small room for a day or 2 days and be able to push or to advocate for something. What would you like that something to be? And Deb, I will start with you.
Yeah, I was going to say, actually, I'd love to use my answer maybe to respond to the platform analogy, because I do think that is a really nice analogy that sometimes gets overlooked. People don't always understand the similarities between the types of I really do think some people are even describing large language model APIs as a type of platform of itself, interacting with various types of users. Of course, there's differences in terms of developer users and end applications and the way that release works, but the analogy is actually pretty useful to think about. So one is like, a lot of the early challenges around, hate speech, harassment, misinformation, the lack of curation on these platforms started with marginalized communities, the LGBTQ+ community, like female advocates, marginalized communities were sort of the first group of folks that were really experiencing some of that early hate speech. Also, folks in the global south were going through a lot of the political misinformation campaigns, the initial political information campaigns. And so something that I bring up a lot when trying to advocate for paying attention to the real world harms done on marginalized communities today is that a lot of those harms become worse and escalate in terms of scale and affect a broader population in the way that we saw with platforms.
Sorry, because we're
okay. Can I just say like too
time.
many things?
No, I'm sorry, I can't.
Right.
So I will consolidate your statement into canaries in the coal mine are always the marginalized community.
For sure,
So as we think about harms of generative AI models, maybe one good way to start with an evaluation is think through marginalized communities and how they're being impacted as a starting ground for how it's going to bleed out to the rest of the world. So Laura, to you.
So that plus one, and then I would say, think through how do you know if an AI system is safe? The answer will be somewhere around, well, we'll evaluate it, audit it, assess it, and then we'll know. It's like, okay, then now think through all the evaluations that you have planned,
Right.
and will you actually know whether it's safe? Because I suspect that we have huge gaps in how we're going to assess these systems, and we don't actually currently have the capacity to know whether they're fully safe.
So I would say yours is something like standardizing how we're even thinking about evaluations and audit. And I think, Deb, you had sort of started to talk about that in your presentation as well. And then Toby.
Great, yeah. So I would say that we need better scientific understanding of these systems and what they can do, what they can't do, how they behave in different settings. And then related to that, I think, it'd be great if along the line we have better ways of getting expert consensus on what the different risks are, because we understand the systems really well.
And then I would then interpret yours as more empirical evidence, like just we need more data, more information. All right, well, thank you so much, all three of you, and thank you for your time.
Thank you.